So we're going through some examples then of research design. So remember that every line represents a different group of people, every O represents observations, every X represents a treatment, and as we move from left to right, we're looking at time. So this is an example of a pre-test, post-test control group design. Now again, we're not using random assignment, but we are trying to use the design elements to create a stronger argument for the fact that our treatment actually has an effect. So are the people in line 1, which would be group 1, the same as the people in group 2? No. Are they randomly assigned? No. They're likely different. That's why we're doing a pretest. So we basically give them our DV before we ever do an intervention. And we very well may find they're different. For example, we might find the mean of group 1 is 3 and the mean of group 2 is a 5. So we have a 2 and a 5 as our start point. Now, if we put our intervention into that first group that started with a 2, and we find that they go up to a 4, okay, so that may mean that our treatment, but maybe people are just improving in general. But if our comparison group, our control group that had a 5 stays a 5, that's a stronger argument that our treatment actually affected the difference. In other words, a lot of the arguments that we could make without that second group and without that pretest, so again, if I don't have random assignment, I don't have another group, I could always say, well, maybe this group's just different, maybe this group is naturally improving, but I've got an argument now that in a group where I did not use the treatment, I didn't see improvement, but I did see improvement in the group that actually got the treatment. Now again, we're not to causation, but we're to a stronger argument that our treatment may indeed be having an effect. So again, the O's indicate different waves of measurement with that subscript. So O1 is our first measure and O2 is our second measure. X is our treatment and it's only occurring in that first group. Each line represents groups, therefore there are 2 groups, 1 line for each of the groups. And if I was using random assignment, I would note that here. So R, if I put it in, would indicate the groups are randomly assigned. If you don't see an R, generally speaking, you might put an N for non-random, but a lot of times this will be just left blank when we're making this kind of a notation. And again, the subscripts indicate the time of the measures. So this would actually be a very simple standard experimental design with post-tests and pre-tests. So basically, we are using random assignment, but to make sure random assignment worked, we give them the pretest. We then do the intervention only in the actual experimental group, while the control group does not get the experimental condition. And then we do our DV at the end, our actual observation. So again, this is a pretest, post-test, before and after intervention measurement. Treatment versus comparison group with a randomized experimental design. This is how we would note it using this design notation. Now, often what we're using with this design notation is to kind of plan out plans to get rid of, again, possible objections to the fact we don't have random assignment. So here's a couple examples of some more complex designs, honestly. And again, observations is the measures. Time is as we're moving from left to right. Treatments are the start of interventions, and then the actual X with a line through it, which unfortunately is not shown very well here, but I'll note it as we go through, is the treatment actually being removed. So what we might have, for example, here is this would be a really good design if we were actually looking at potentially trying to do an intervention within a school system. We may be able to go into the school system and say, hey, we want to put this new kind of technique in, but what we'd really like to do is one of your classes gets it and one of your classes doesn't. And at that point, the instructors might go, well, we don't feel very comfortable with that. Then what you might say is, well, you have a 16-week class. What if we allowed the intervention to be in the first class for the first 8 weeks and then removed it, and then we'd allow it to be in the second class for the second 8 weeks? That way, both classes are getting the intervention. Now, this allows us to be fair, but it also allows us to set up a pretty good design. At that point, at the very start of the semester, I give my first observation in both classrooms. That's O1. I measure basically the pretest. Then in class 1, they get the intervention for the first 8 weeks. The second class doesn't get the intervention. And then at the end of those 8 weeks, I measure my outcome again. That's O2. At this point, in the first group, I would actually remove the intervention, while I add the intervention to the second group. And finally, at the end of the semester, I would measure a final time, 03. Now, what we would find here at this point is if we actually were wanting to make an argument, if we found that in the first group, we actually found an improvement from time 1 to time 2 while they were getting the intervention. However, from time 2 to time 3, there was either no improvement or they actually got worse. And likewise, in group 2, we saw no improvement or maybe even got a little worse between time 1 and time 2, but then we see an improvement between time 2 and time 3. This would start to make a very strong argument that our treatment has an effect. We find it in either group when it's present, and we don't find the improvement when it's not present. So again, just those elements of design. When you're always creating a design where you can't use random assignment, and even when you're using a design that does include random assignment, it's a good idea to ask how many pre-tests and post-tests are necessary. Just realize the more tests, the clearer the pattern. However, the more tests, the longer it's going to take. And you may also get some testing fatigue effects. They start taking the test over and over again. Again, how many comparison groups do you need? It allows you to check for confounds. It allows you to make a stronger argument for generalization, and is especially useful if pre-tests are not practical or random assignment is not practical. And again, the more comparison groups you have, the stronger it is to make an argument for generalizability. And again, for treatment, how can the same treatment be tested differently? Does giving the treatment have the same degree of effect as removing the treatment? And again, that is something to think about as we design a study. So there's also, of course, sometimes you may not even be able to add a control group. So these are some examples of designs without a control group. So the first design is a pretty poor design. We add treatment and we do a post-test. At that point, all we can say is, it looks like they got better, but I don't know what they were at to begin with. We can do multiple post-tests. So again, we can add multiple follow-up measures. And this might be an example where the intervention has already happened. So the intervention happened. I can't get pretest scores, and all I can do is try to measure whether or not the actual intervention had an effect. I would get a little bit more information if I did multiple follow-ups, in other words, multiple DVs at the end. That's the second area where I measure it once, twice, and 3 times, because then if it really did have an effect, does it have a lasting effect? Obviously, what we would hope to do is be able to at least do a pre-test, post-test design. It provides a better estimate of effect, but it does not control for confounds, but at least it tells me that here's where they were, here's the intervention, and here's where they were after the intervention. A better design would be some form of introducing and removing the treatment from the same group. So again, I measure my DV, I install the treatment, I measure the DV a second time, maybe even a third time, then I remove the treatment, and then I measure it a 4th time. So generally speaking, we often refer to this as a repeated treatment design or an ABAB design. We introduce a new treatment, we remove the treatment, reintroduce the treatment. So again, in this case, we've got an observation, 1, we've got a treatment added, we've got a second observation, we remove the treatment, we have a third observation, we've got the treatment again added, and we've got a 4th observation. So if I find improvement, reduction, and improvement, it starts to become hard to think that something else is occurring in exact sequence with me adding and removing that treatment. Another tool we can use in this is that if we don't have access to pretest data, we could ask people to recall what they were like prior to the intervention. This is often called a retrospective pretest or a calendar recall. And again, it's better than not having that data at all. Obviously, generally speaking, we want designs with control groups. Most often what we have is the post-test only design with non-equivalent groups. And again, if we've got random assignment, we can assume that the 2 groups were equal to begin with. But if we don't have random assignment, we just don't know if the groups were different to begin with before we tested them because we don't have pretest. It's weak, but at least we don't have testing effects. Ideally, we want post-test and pretest only. Now, sometimes you'll see a dotted line in a study. What that refers to, if you see a vertical dotted line, it actually means that we did a pre-test and post-test on similar groups, but our actual intervention and outcome and control group are a different group. This happens in education a lot. So, for example, I might have Mr. Simmons' class and Mrs. Ettling's class. Mrs. Ettling's class is a second grade class. Mr. Simmons' class is a second grade class. And I have their performance, O1, from both classes last year. I do an intervention in Mr. Simmons' class this year. I don't do it in Miss Ettling's class. And then I look at the outcome at the end of the year. I can at least kind of try to capture maybe the differences in their teaching style by that post-test only using an independent pre-test sample. We can also have an untreated control group of the pre-test and post-test. This is probably the most common quasi-experimental design. It's simple, but includes most of the best components. And again, in this case, we've added both that pre-test, the intervention, the post-test, but we also have a comparison group, non-equivalent, but we again have their pre-test and post-test. And we can account for the fact that they may be different, but we're asking, do we see the same level of impact in the group that doesn't get the treatment? And finally, we kind of talked about that AB design. We can also do that with control groups as well, where we basically are adding and subtracting various interventions down a series of observations to see if the effect is actually following the pattern we'd expect it to. Now, again, none of these are necessarily going to give us a strong argument for causation, but they do help us eliminate a lot of the potential other explanations for the impact of a treatment if we find it. So again, elements design, how many times, and again, this is just kind of repeating what we've already talked about, but I just want you to remember that the big things that we're usually looking at is adding or subtracting treatments, adding or subtracting comparison groups, and adding or subtracting pre-test and post-test measures.